Okay, in an earlier video, I used an expenditure minimization to drive the expenditure function, and in a different video, I used the utility maximization to drive the value function. In this last little clip, I just want to show you how the two relate to each other. And when we talk about the two of them relating to each other, we're referring to a concept called duality. Okay? Quick review. Sorry, I'm trying to get my video straight here. Okay. When we do a utility maximization, what we do is we solve for the optimal levels of consumption of the goods. Then we can take those optimal levels, plug them back into the utility function. That gives us our value function. And what the value function is it's a function of the parameters, prices and income, prices and wealth. And what this new function does is it gives us the optimal level of utility, or the amount of utility that is achieved at these prices and that level of income. So if I have $50 and C costs $5 and G costs $1, this function will tell me how much utility I will get from that scenario. Alternatively, for the expenditure minimization problem, what we have is that we solve for the optimal levels of good C and good G, and we plug them into the expenditure function. And what this does is this will give us the amount of income that it will take to achieve a given level of utility, given the prices that exist in the market. So if I want to achieve this much utility, and C costs $5 and G costs $1, I will need this much income. Okay? Now these two concepts, they relate to each other. As you can see, the value function gives me a certain utility amount. Also, the expenditure function gives me a certain income amount. So you can see that these two might relate to each other. For example, if I took the value function, because it equals a utility amount, if I plugged it into the expenditure function wouldn't change. It would still equal I. In fact, it would equal this I. So let me show you here. If I had the value function, so this goes both ways. I have the value function. If I plug the expenditure function into the value function, I will get U back, because expenditure function equals I. Likewise, for expenditure function, if I have my expenditure function and I plug the value function into the expenditure function, I'll get I again. So there's this particular relationship, and I just want to illustrate for you. I just want to show that this is true. I'm going to show that the first one is true. I'm going to leave the second one for you to do the algebra to show that it's true. So in the other videos, I used the utility function U of C of G equals square root of CG. Okay, this is the utility function I used in the other examples. So now what I want to do is I want to show you that these relationships hold. Okay, so when I did the utility maximization, that yielded this value function. Okay. And when I did the expenditure minimization, this yielded this expenditure function. Okay, so then I'm just going to show that this is true. That's all I want to do. When I want to show that utility holds, or that duality holds, I'm just going to show that this is true. So I'm going to take my value function. Okay, this is my value function. I'm going to plug the expenditure function into it. So the expenditure function equals I. So I'm going to plug the expenditure function in for I. So it means instead of I, I'm going to write the expenditure function, U, or 2 times U bar PC PG. Okay. divided by 2 PC PG. All right, I write that, and then I notice 2's cancel out, square root of PC PG cancels out, and U equals this. Or it equals U bar. Okay, I'll leave the other one for you to show. All right, thank you.